converting within the metric system. So the first thing we have to know is the relationship between meters and kilometers. And you can look at your chart of prefixes, but this is something that you'll need to have memorized, and you'll need to know the relationship. And you've worked with these things before, so a lot of you already know that there are 1,000 meters in 1 kilometer. And the other thing you need to know when you're converting from one thing to another is sometimes you're going to use that relationship of the 1,000 meters is 1 kilometer and multiply, and sometimes you're going to divide. Now, kilometers compared to meters, one is big and one is small. Whenever you're comparing two measurements, comparing them together, one will be a bigger one and one will be a smaller one. Like if I do centimeters and millimeters, centimeters is the big one, millimeters is the small one. But if I do centimeters and meters, well, now centimeters is the small one and meters is the big one. And so when you're converting from something big to something small, imagine you have 100 kilometers and you went out and bought, these would be really kind of awkward, but kilometer sticks. This is a meter stick because it's a meter long. Imagine you have in your backyard these long sticks stacked upright into the air that are kilometer sticks. And you want to find out how many meter sticks would equal 100 of these kilometer sticks when you lay them down. Just visualizing it, can you see that you would need a lot more meter sticks than kilometer sticks? So when you're converting from big to small, you realize I need a lot more of these. And if you're thinking about that, you're going to ask yourself, should I multiply by 1,000 to get more of them, or should I divide by 1,000 to get more of them? And in this case, we're going to need to multiply by 1,000. So when I take 100 and I multiply it by 1,000, I'm going to get 100,000 meters. Sometimes what people like to do, so there was one way of doing a conversion. You make the realization, think about the units and say, which one's bigger, which one's smaller, what makes sense? Should I multiply or should I divide? And in this case, kilometers are bigger, so we would need to multiply because we would need more of the smaller one to make them equal. Another thing that sometimes people do in a case like this is they start with their ratio like this and say, I want to find 100 kilometers. If I go from 1 to 100, would I multiply or divide by something? I multiply. And from 1 to 100, I multiply by 100. So on this side, I would have to do the same thing. Because sometimes you might be dealing with prefixes that you're having trouble with figuring out which one's bigger, which one's smaller. So sometimes this method off to the side makes more sense to you. You're like, okay, if I want to go from 1 kilometer to 100 kilometers, I'm multiplying by 100, so I'd have to do the same thing on this side. And it's kind of similar to what you've done in grade 9 with equations, where what you do to one side of the equation, you do to the other side of the equation. 100 millimeters to centimeters. So here, this is the small one. This one is the big one. What's the relationship between millimeters and centimeters? 10 millimeters is 1 centimeter. So going from small to big, well, as soon as you have a bigger thing, you're going to need less of them to be equal. So in this case, we would divide by 10. Which would give me 10 centimeters. There. Because I would need less of them. So the one technique that we're using so far is the idea of big and small, multiply or divide. The other technique that I've done off to the side is going to be the same whether it's big or small or small or big. So in this one, What do I know? I know what 100 millimeters is, so I want to find what 100 millimeters is. What do I have to do to go from here to here? Multiply by 10. So I would have to do the same thing on this side, multiply by 10. And 1 times 10 is 10. Same answer. But what's interesting in this example is one place we divided, right? We said we went from small to big, so I'll need less of them, so I'm going to take the 100 and divide by 10. And over here, I still multiplied. So that's going to be something, think about that, see if both of those methods make sense to you. Often, when we're doing things, I might show you more than one method. And when you have to do the question, like if you have a conversion question like this, you're going to have the choice. But knowing more than one method is powerful, because there's sometimes in math, if you decide to just learn one method, it will work. But there's sometimes in math where one method is shorter than the other method. And, I mean, I love math, but I also like doing math quickly, which seems to be, if I love math, maybe I should always take the longest way to do it, but that somehow finding the shortest way is more fun. And even if you don't like math, you like doing the shorter way, because then you're done quicker. So the thing about math is one method might be shorter most of the time, but another method, there might be one time where you're like, oh, that is way shorter in this case. So I like knowing them both, because sometimes one is more helpful than the other. Now we're in milliliters. Milliliters to liters. So we've got the prefix of the little m, which means that there would be 1,000 milliliters is 1 liter. So here, this one is the small one. This one is the big one. When going from small to big, you're going to need less of the big one to make them equal. So we're going to have to divide. 150 divided by 1,000. Dividing by powers of 10. How do you do that? Yes. You move the decimal point. So if you're dividing by 10, you move it once, because that's a 10th place. If you divide by 100, you move the decimal 2 to the left. And if you divide by 1,000, you would move your decimal 3 points to the right, so that would end up being, okay? Now, that's if I'm moving it 3 to the right. Sometimes we add a 0. If you don't have that 0 in front, it's not wrong. But often you'll see in textbooks they'll have that 0 in front. I kept the 0 here, so it matched with my 150 that was there, but in reality we don't need this 0 at the end, because 0.15 is the same as 0.150. But in this case, I kind of like putting that 0 there because it makes me feel like I've moved it 3 decimals to the left. Dividing by 1,000 here seems a lot better than this method. In this one, on the right, so all the way along, if you've been liking the right method so far, we've gotten smaller, so we've divided by something. Do you know what you've divided by? No, it's not an easy mental math thing to do. I can write it as a fraction for you if you like.
Can you do it in multiple steps?
You could do it in multiple steps, and that's not a bad thing to do. So, I really like that, because the number that we would put here is going to be, we just divided by, well, we actually divided by 1,000 over 150, which is not a nice number to put. Okay? But multiple steps might look like this. Really like that. Really, really like that. Go, I want to get, in the end, 150 mils equals something in liters. An easy thing for me to do would be to find out what mostly easy, right? Find out what 1 milliliter is, okay? I can do that by dividing by 1,000. And dividing by 1,000 on this side would be moving that decimal 3 places to the right. So I have my decimal right there, moving it 1, moving it 2 would include a 0, moving it 3 would include 2 zeros. Decimal 001. And then for going from 1 to 150, here I would multiply by 150. And so if I take this and multiply it by 150, and again, I don't know how strong your mental math with decimals is, that comes up to 0.150. This is a great example where I like what's happening on the left a lot better. Because you just had to do one thing, and you figured it out. Okay? The thing that happens on the right, though, has some really powerful math. Because what we ended up finding here, and I'm going to use the word cost. We could write unit value, but I'll use the word cost because it most often happens when you're dealing with money. And so you're wanting to find out if 8 bananas cost you $5, how much is it going to cost if you buy 12 bananas? So you would have to figure out, well, if 8 bananas cost me $5, I could find out what 1 banana cost me. 62.5 cents. You could, and then multiply by 3. That's a fire drill. We go out these doors, down to the staff parking lot. Where we left off. And move on to D. Sometimes, depending on the base unit, you might really feel like you don't know what these units are, right? Grams, you're okay, but centigrams? I'm not sure. The most common one that you're used to, if we go back to our base units, you're most used to your meter, right? And you're most used to converting between meters and millimeters and centimeters and kilometers. And so, on a question like this, where you have 15 grams equals how many centigrams, you can kind of think in meters. What's the relationship between centimeters and meters? And it will be the same as the relationship between centigrams and grams. So since there's 100 centimeters in a meter, there would be 100 centigrams in a gram. And so the gram would be the big one, and the centigram would be the small one. And when we're going from big, if we have a bunch of big units, and we want to say how much they are in smaller units, you're going to need more of the smaller unit. So going from big to small, we're going to need to multiply. So we would multiply by 100, and we'd get 15, multiply by 100, got a little bit zero happy there, and we would get 1,500 centigrams. Same thing here, we could use this technique and say, if I want to find out what 15 grams is, I've multiplied by 15, so I would need to multiply by 15 on this side and get 1,500 centigrams. I would like you to finish the last two, and I'll put up the answers in a little bit. So meters to kilometers, this is the small one, this is the big one. So you would need less of the big one. We know that there are 1,000 meters in 1 kilometer. So we could divide by 1,000, move the decimal 3 places to the right, or to the left, sorry, and you get 15.677. Now in the last one, we're going from kiloliters to centiliters. So if we look at our prefix chart, we're going from here to here. Okay? Which is a little bit complicated because almost everything we've used so far has got us to our base unit. So something we can do to think about this. We know that there would be 1,000 liters in 1 kiloliter, and we know that there are 100 centiliters in a liter. So sometimes what you might want to do in a situation like this is take an interim step and do one conversion first. Maybe I take my 150 kiloliters and say, I know that that would be how many liters. And again, this is your big one, this is your smaller one, and so we're going to need a lot more of the smaller one to make them equal. So I'm going to multiply by 1,000, and I have 150,000 liters. And so I know that 150 kiloliters is 150,000 liters. And then my next step is, well, now that I know how many liters I have, could I change that to centiliters? Again, this is my small one, and this is my big one. And so again, I'm going to need more, so I'm going to multiply again, and now I need to multiply by 100. So I have 4 zeros already. When I multiply by 100, I get 2 more zeros. So our final answer here is 15 million centiliters.